to section 1.5. We're talking about solving inequalities. More review of some Algebra 1 concepts with inequalities. The good news is equations, an inequality is really just an offshoot of an equation. The only big difference is going to be talking about what a solution for an inequality will look like compared to the solution of an equation. And as far as graphing those solutions on number lines, it's going to be a little different because we didn't have to worry about that with an equation. We'll talk about those differences as we get through this section. Make sure you have your note sheet out in front of you as we work through the example problems together in this video, and then I'll give you some time to work on some practice at the end of the video, which we'll discuss in class, as well as any questions that you have from watching this video. All right, so let's just talk a little bit about solving inequalities. Okay, as you see here in these notes, the algebra involved is just like the algebra you would have when you're solving an equation. So for your first example, solve the inequality 3x minus 12 is less than 3 and graph the solution. So we'll do all the algebra that we would do normally to get the x by itself. We'll undo the minus 12 by adding 12 to both sides. And then we'll get 3x is less than 15. We need to undo the multiplication of 3 by dividing by 3. And then 15 divided by 3 is 5. So now our solution is x is less than 5. Now notice something we didn't have with an equation. This little phrase here. Graph the solution. Okay, when we solved equations earlier in this chapter, we got one answer. X is 4, for instance. Okay? When you're dealing with an inequality, now you're talking about multiple answers. So in this first problem, we're saying that every x that is strictly less than 5 makes the inequality 3x minus 12 less than 3. Okay, so to visually represent that fact, we're now going to go to our number line, and we're actually going to draw a graph of this inequality x is less than 5. So reminder of that, we're going to do an open circle around the 5 because that shows our reader we're talking less than 5 strictly and not equal to 5. And then we're going to shade all the way across all the numbers less than 5, including the left arrow, which tells us we keep going on and on, even though we cut off the number line there. Okay. Now the only key difference, and you saw this in Algebra 1, but I'm going to keep reminding you of this to brush off the cobwebs. Whenever the algebra requires you to multiply or divide by a negative number, you must reverse the inequality symbol. Okay, so here's an example, a little more complicated one where that's going to come up. So we've got 6 plus 5 times the quantity of 2 minus x is less than or equal to 41. All right, our first step will not be to add the 6 and the 5 because we have multiplication here next to this 5. And order of operations says multiplication trumps addition. So our first step will really be to distribute that 5 into our parentheses. So we get 5 times 2 is 10, and 5 times negative x is negative 5x. Now we can combine our numbers. Okay, and then we're going to do some similar things that we did in the last example. We'll subtract 16. And that's going to get me 25. Then I'm going to divide both sides by negative 5. But I divided by a negative, so I've got to take this less than sign and make it a greater than sign. So my solution will look like this. I want to note about how I do these on number lines. I really don't get that fancy with them. I just put in 0 for a point of reference, and then I just put negative numbers to the left, positive numbers to the right of wherever I put the 0. I'm really not going to make you do a bunch of tick marks. I think at this point I get that you know how to shade number lines. I'm more going to be looking for, do you have the right values? Do you have an open circle when you need an open circle? Do you have a closed circle when you need a closed circle? Are you shading in the right direction? That's the things that I'm going to be looking for when I grade things like this, okay? Just so you know. All right, let's look at a couple more examples. All right, so same idea. We're going to add 6 to both sides first. Divide through. X is less than 11. So I'll put in my 0 for a frame of reference. Put in my 11 because that's part of the solution. Open circle because there is no bar. And then I will shade. This pen does not like me shading. Here we go. There you go. Okay? One more. So we've got 12 is greater than or equal to 2 times the quantity of 3n plus 1 plus 22. Again, like we saw on the last slide, first thing I want to do if I see parentheses like that with a number in front, my handy-dandy distributive property. So 6n plus 2 plus 22. I'll combine the numbers on the right. And I'll send the 24 over to the left by subtracting. So we have negative 12 is greater than or equal to 6n. Okay, now I'm going to divide through by 6, and I put this problem in here on purpose. Please take note of this. This is something where students can make a mistake with inequalities. Some of you may be thinking, I have to flip my sign because negative 12 divided by 6 is a negative number. Pay attention to the rule. My answer is negative 2, but I did not divide by a negative number on the bottom. The negative was up with the 12. I will not flip this. This stays a greater than or equal to sign. Okay. Also be careful. Sometimes they like to put the letter to the right for your final answer. Sometimes students get tripped up by that when they come to shading. They see a greater than, and they think that means you got to shade this way. But look at where it's pointing in relation to the n. We're saying negative 2 is bigger than all the values of n that you want to come up with in your solution. So we actually want to shade to the left on this one. Okay? And if you don't believe me, pick a number that's in the shaded region, like negative 4. You put it in for n. Is it true that negative 2 is greater than or equal to negative 4? I think so. So that's where negative 4, the shaded region, needs to be in the spot on the number line where negative 4 is. And I think you would all agree that if negative 2 is here, negative 4 is going to be somewhere over there. Okay? Now let's look at some special examples here, some special cases of what happens with some inequalities. So I have a couple here for you. We have 2x minus 3 is greater than 2 times the quantity of x minus 5. All right, so let's get rid of the parentheses first. Distribute the 2 on the right, and I get 2x minus 3 is greater than 2x minus 10. Okay, so I've got variables on both sides. I need to get them all to one side, so why don't I bring them over to the left? So I'll subtract the 2x from the right and from the left. But look what happened here. We got the 2x's to cancel out on the right, which is what I wanted, but since they both had 2's, they actually cancel out everywhere. So I get negative 3 is greater than negative 10. And I sit and I think, and I don't switch the slide. There we go. I sit and I think, negative 3 is greater than negative 10. We saw this when we had equations too, remember? The letters would cancel out, and then we had to ask ourselves, does this statement that we're left with make sense? Is it true or is it false? So is it true that negative 3 is greater than negative 10? I think so. On a number line, this number, negative 3, is much closer to 0 than negative 10, and the bigger numbers are out towards the right. So I think this is true. So guess what that means? Since this is true, always and forever, this is also true, always. So what does that mean for our solution to this inequality? That means all real numbers is our solution to this inequality. Pick any number you want for x, 9, negative 17, pi, square root of 7. It will always hold. This inequality will always hold for those numbers. So on our number line, you can put in a 0, sure. But we're going to shade the whole darn thing. Every number is going to work. Okay? Now let's look at the second example. And if you're astute, you may know where we're going with the second example. All right, so we're going to distribute the 7. Same thing, I got to get the letters to one side, so I'll subtract 7x from both sides. But, I have a 7x on both sides, so all the x's cancel. I'm just left with this statement. 6 is less than negative 28. Well, there's no way 6 can be less than negative 28. It's a positive number. It can't be smaller than a negative number. So that's false. It will always be false that 6 is less than negative 28. So, by logic, that must mean this is also false. So if we have a false inequality, that must mean there is no solution. There is no value for x that is going to make this inequality true. So this is basically a blank number line. You don't have to shade it. That would be the graph of that answer. Okay, so be mindful of that. Just like we were mindful of that with equations, where occasionally all the letters would cancel, and we had to ask ourselves if we had a true or false equation. Well, same thing can happen here. We can have a true or false inequality, and that corresponds with either all real numbers or no solution like it did with equations. Okay, let's just look at a couple tougher examples. Let's build this back up to where you were in Algebra 1. All right, this one's tough, this first example, because there's a fraction, a big old fraction on the right-hand side. So to clear that out, I want to undo the fraction by multiplying both sides by -4. Because remember, fractions are division. So we're just undoing the division by multiplying. So I get -32y is greater than or equal to -5y plus 9. Okay, let's bring the 5y over to the left. We'll divide through by -27. Whoop, 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 whoop. Dividing by a negative number. Gotta flip our inequality. Y is less than or equal to -1/3. Okay, the directions don't say to graph these, so we're just going to leave it at that. All right. Now I got letters on both sides. I've got parentheses on both sides, so I got to clear them out. I'm going to do a whole lot of distributing. So I'll multiply the left-hand side by -5. I get -15d plus 35. I'll distribute the right-hand side, 6d plus 42. Get my letters to one side. How about I add 15d this way? They cancel on the left. I get 35 is greater than 21d plus 42. I'll bring the numbers to the left because I brought the letters to the right. I get -7 is greater than 21d. Divide through by 21. And I get -1/3 is greater than d. Okay? That's really all there is to it. We're going to take a look at some word problems. We'll maybe look at some more of these tougher kinds of examples too in class, just to build up your skill with this, so that way we can get you where we need to get you for the end of the chapter. We're going to see inequalities again near the end of the chapter when we start talking about compound and absolute value inequalities. With that, I bid you a good evening. Bring any questions you have from this video to class tomorrow.